Hello, ladies and gentlemen. Welcome to Chapter 8, Section 3. Here we're talking about reflecting points and graphs. We'll start by talking about some things. When we reflect graphs, reflect lines and parabolas and so forth, essentially all it is for us, really all it does is when we reflect it, to show that we're reflecting it, we put a negative sign in front of our absolute value or a negative sign in front of um, our x squared. Okay, and then we'll talk about the reflecting the points, how when we what it means to reflect over the x-axis and what it means to reflect over the y-axis and so forth. So let's take a look at some uh, graphing absolute values and graphing the uh, reflections there. So we're going to start off with our base absolute value graph, which we should know by now, hopefully, is just the V that goes up 1 over 1 on each side of our absolute value, or each side of our graph, like so. Okay, so now we're asking in this next example that we'll see in red here to reflect it. Okay, so this negative sign means that we're going to reflect it. So we're going to still put this first point, basically what's going to happen is just going to stay at 0, 0. But everything else is going to reflect and become the opposite. So positive 1 becomes negative 1. Positive 1 becomes negative 1. So we just flip the graph upside down. And the reason why it's called a reflection, and this should be down one far, sorry, there. And the reason why it's called a reflection is because if we look at it, it's almost like the graph is looking into a mirror. Okay, so here's our original, here's the reflection. This would be, if you think about looking at, pictures of lakes, how this is the top, and then this is what it looks like in the lake. That's what we have here. So now in blue, we're going to graph the line negative, or the opposite of the absolute value of x plus 4. Our rules still stay the same. The plus 4 is on the outside, so we go up 4 and put our first dot. But now instead of going up 1 over 1, we go down 1 and over 1. So because of that negative sign, it flips our graph upside down. But our rules as far as how we move stuff and so forth still remain the same. Alright, and then the last example here in green, the opposite of the absolute value of x plus 2 minus 1. So because that plus 2 is on the inside, we're still going left 2. Remember that it's opposite when it's on the inside. And then we go down 1, so that's our first initial axis point. And then because it's negative, we go down 1, back 1 each time. Alright, so that is reflecting the absolute value. Okay. Now for graphing parabolas, it's the same process that we go through. Alright, so the first parent function x squared looks like this for us. Alright, and that's that U shape that we should be hopefully coming accustomed to and working with. Okay, and now it's the same idea when we reflect. We have negative x squared, the 0 still stays the same, but all of these values reflect or flip to the other side, and then they become opposites, and we have our reflection of our graph there. Okay, the same idea applies as far as our rules go with translations. We have a negative 2 that's not inside parentheses, so that means it's going to go down 2, and our graph simply just goes down 2 spots, and because it's negative, it's upside down, so it's that way. Then we have the x plus 2 and then the minus 4. So what we've got here is it's a minus 4, so we're subtracting, or it's a plus 2 on the inside, so that's left 2, and minus 4 takes us down here to there, and then our graph is upside down, so it's graphed upside down, like so. All right, so the rules for graphing parabolas and graphing absolute values are the same. So now we'll take a look at graphing and what it means to reflect points. So when we reflect points, we have two different ways that we can reflect points. We have reflections over the y-axis and reflections over the x-axis. So we have these ordered pairs on the left are the original points. The ordered pairs on the right are what their ordered pairs will change into. So we're going to start off with the ordered pair 3, 4. That's right, 3 up 4. A reflection over the y-axis means we're going to reflect over this axis, meaning we're going to take our point and reflect it to the, in this case it's going to be to the left. So what's going to happen is our point here is going to move from here, and since it's 3 spots to the left of the axis, or to the right of the axis, it becomes 3 spots to the left of the axis. So this original point we said was 3, 4. We now see that the x value of the point is the only thing that changes, so it becomes -3, 4. Okay, so then in our second example, we start with the example -2, -4. So it's going to reflect over the y-axis, which means it's going to reflect to the right, and then it's going to turn into +2, 4. Okay, so it's going to be, it's 2 spots there, so that means it's 2 spots there, becomes +2, -4. All right, the same thing applies when we reflect over the x-axis. So when we reflect over the x-axis, we're going to reflect up and down. All right, so we're going to start with this 3, 4. This first example, we reflected over the x-axis. It's 4 spots above the line. So that means it's got to be 4 spots below the line. So this is the new point there. We can see that it's 3, -4. All right, so the only thing that changes is the y value of the point. So now we have the same example here with our second dot. We reflected over the x-axis, so that means it's got to be up 4 from the graph here. So it becomes -2, so back 2, up 4. All right, so when we think about this, all we're changing is those ordered pairs. All right, is the ordered pair reflecting over the y-axis changes the x value, reflecting over the x-axis changes the y value. If you have any other questions, just let me know, and have a good day.